have to prevent the oxidation of copper into copper oxide. The data is given here, and we have to find the minimum partial pressure of hydrogen so that we can prevent the oxidation of the copper to copper oxide. The oxidation of the copper can only be prevented when we can stop this reaction. Okay, when this reaction will not occur, that means there will be no oxidation of the copper. Now then, how to stop this reaction? Because reaction is occurring at 1250 degree Kelvin at high temperature. If the Gibbs free energy of this reaction is 0 or greater than 0, that is positive, then we can stop this reaction. If the Gibbs free energy is negative, that means this reaction will be spontaneous and there will be the continuous oxidation of the copper. We have to use the concept of Gibbs free energy to solve this equation. Standard Gibbs free energy was for two reaction is given, and this oxidation reaction is given. Value of R and temperature is given. So first of all, we have to write the Gibbs free energy equation. That is Gibbs free energy equation. Gibbs free energy equation. Okay. What is the Gibbs free energy equation? That is delta G is equal to delta G0 plus RT ln K. Clear? What is delta G? Delta G is the Gibbs free energy at any other temperature except 298. At 298, that delta G will become delta G0. That will be the standard Gibbs free energy. Means at 298 Kelvin, it will be standard Gibbs free energy. At any other temperature, for example 1250, this will become a delta G. Clear? Delta G0 we have to find. For this, to find the delta G0, these two equations are given. R is given, T is given, here ln K, where K is a equilibrium constant. And this equilibrium constant in terms of gas, in terms of pressure, because here the reactant is a gas, product is gas, and gas exert pressure. That means this K should be in terms of pressure. Here it is in solid, here also Cu2O is in terms of solid, and solid don't exert pressure. So that means ln K will be in terms of gas, in terms of H2 and in terms of H2O. Clear? Now this reaction with this equation, if it is positive means it should be greater than 0 or at 0. Okay, then this reaction will not be possible. That means will not be feasible. When this value, that is delta G value, that means this value should be greater than 0 or equal to 0. At equal to 0, this reaction will be in equilibrium. That means whatever the Cu will consume, same Cu will be formed. At equilibrium, this reaction will be also, there will be no oxidation, because whatever Cu will consume, same Cu will be formed. So we have to find this value, and this value should be equal to or greater than 0. Clear? Now first of all, we have to find delta G0, that is Gibbs free energy at 90 to 98 degree Kelvin. These two equations are given, but this H2O in this reaction, it is in product side, but here it is in reactant side. So we have to reverse this reaction. If we reverse this reaction, this will be H2O gas gives H2 gas plus 1/2 O2 gas. When we are reversing this reaction, the sign of delta G0 will also be get reversed. So delta G0 for this reaction will be plus 178,000 joule per mole. Okay, this will be the value of delta G0. Now we have to add this reaction, that is reaction number 1 and reaction number 3. So we will get this reaction, that is 2Cu solid plus H2O gas gives Cu2O solid plus H2 gas. Okay. When we are adding the equation, that means Gibbs free energy will be also get added, because it is energy and this is additive. So we have to add this value and this value. So delta G0 for this reaction will be this plus this. So 78,000 will get cancelled. It will become 1,0,0,0 joule per mole. Okay. Now we got delta G0 for this reaction. We got this value. We know R, we know T, and we know K, that is equilibrium constant. So we can write this reaction here. That is delta G0 is 1 lakh 10 raised to power 5. 1 lakh means 10 raised to power 5 plus R is given 8 into T is given 1250. Okay, and ln Kp. What is Kp? How to find Kp? Kp is nothing but equilibrium constant in terms of phi. So partial pressure of the gas H2, that is partial pressure of the product divided by partial pressure of the reactant, that is H2O. So it will become partial pressure of H2 gas and partial pressure of H2O gas. Now we have to solve this equation. After solving this equation, we will get the value of minimum this. This should be greater than or equal to 0. Now 10 raised to power 5 plus 8 into 1250, it will become 10 raised to power 4, 10,000. Okay, into ln pH2 minus ln pH2O. Okay, greater than or equal to 0. This is another term, so this will go this side. So here will become 10 raised to power 4 ln partial pressure of H2 minus ln partial pressure of H2O. Okay, it will go this side, minus 10 raised to power 5. Now this term is in multiplication, so if this will go this side, it will be go in division. So this will go in division, divided by 10 raised to power 4. Okay, so now ln partial pressure of H2 minus ln partial pressure of H2O greater than or equal to, this will get cancel, it will become minus 10. We have to find ln pH2, that is means ln partial pressure of hydrogen. So ln partial pressure of hydrogen greater than or equal to minus 10, it will become plus partial pressure of water. What is partial pressure of water? It is given. What is given? What is given here? When we are passing the N2 gas to prevent the corrosion of copper, that contains 1 mole percentage of water. That means percentage of water is 1 mole. That means 1 by 100. It is 0.01. And this pressure is directly related to the mole fraction. Clear? So total pressure is 1 bar into its mole fraction. It will become 0.01. Okay. So 0.01 is the partial pressure of the water vapor. So it will become ln 0.01 bar. Okay. We have to solve this greater than or equal to minus 10 plus we have to convert ln into 2 log 2.3 log ln 0.01, that means 10 raised to power minus 2 greater than or equal to minus 10 plus 2.302 into, it will become minus 2 log 10 will be 1. So greater than or equal to minus 10. This is minus, that is minus 2.3 into 2, that is 4.6. So it will become minus 14.6. So ln pH2 we have got minus 14.6. So we have already calculated the ln pH2, that is minus 14.6. But we can also calculate the pH2. Partial pressure of H2 greater than equal to, it is ln, so it will become minus 14.6. We can also calculate the partial pressure of hydrogen, and that partial pressure of hydrogen is e raised to minus 14.6. But that is not required because we have to only find this value of ln partial pressure of H2, that is 14.6. So this is a minimum pressure to prevent the corrosion of the copper. Beyond this pressure, the value will always be positive of delta G. That is, Gibbs free energy value will always be positive. But at minus 14.6 of this value, delta G will be 0. That means this reaction will be at equilibrium. When the value of partial pressure is greater than this value, then the delta G of this reaction will be always positive, and when it is positive, that means this reaction is not spontaneous. Not spontaneous means it is not feasible, and corrosion will be stop itself. This is the solution of this question. If you like it, share and please subscribe to my channel. Thank you for watching.